So, you ready to see the results of the mission? Take a peek. So the first analysis shows samples that contain abundant water in the form of hydrated clay minerals, and they contain carbon, and you could see the carbon there, as both minerals and organic molecules. And at nearly 5% carbon by weight, carbon being the central element of life, a far exceeding our goal of 60 grams. This is the biggest carbon-rich asteroid sample ever returned to Earth. Carbon and water are molecules. The carbon and water molecules are exactly the kinds of material that we wanted to find. They are crucial elements in the formation of our own planet. And they're going to help us determine the origin of elements that could have led to life. And I mentioned that one of our missions, it's actually in statute, is to look for life. That's why we're digging on Mars. That's why we go out into the far regions of the very beginning, capturing light from the formation of the first galaxies with James Webb. Now we're looking at this, and what you're seeing today, there's so much more to learn, and there's so much more now that we have this sample to analyze. And why are we doing this? Because at NASA, we are trying to find out who we are, what we are, where we came from, what is our place in this vastness called the universe. And this mission will help our scientists investigate planet formation for generations to come. And it's going to deepen our understanding of our solar system. And it's going to improve our understanding of asteroids that could threaten us here on Earth, helping us protect our planet. And oh, by the way, do you remember DART? We intercepted it at 7 million miles away, and it was bullseye. And we moved the trajectory of that asteroid. So this sample return is proof, again, that NASA does big things, things that inspire us and unite us. NASA brings us together in unity, and things that show that nothing is beyond our reach when we work together. So now I want to take you to the curation lab here at JSC, where a team of scientists are hard at work since the sample arrived just 2 weeks ago.
Thank you, Administrator Nelson. Now, I know you're all ready to learn more about this sample, and I am here with someone who can make that all happen. I am joined today by NASA's OSIRIS-REx curation lead, Dr. Nicole Lunning, and we are standing just outside of the OSIRIS-REx pristine curation clean room. Nicole, before we get started, can you tell us a little bit more about where we're standing right now?
Yeah, thank you, Courtney. So we're in front of the newest curation lab in Historic Building 31, which is home to the largest collection of astromaterials in the world.
Now, the world just got its first look at this gorgeous sample. Can you tell us about how the curation process has been going so far?
Yeah, it's been incredible so far. On Sunday, September 24th, the sample return capsule landed safely in Utah, and then it was brought to a temporary clean room that we had set up there to have certain parts removed, specifically the heat shield and back shell, which are two large parts, and that exposed the sample canister inside, which a nitrogen flow or purge was attached to protect the sample. And then with that nitrogen flow attached, The next day, Monday, September 25th, it was flown from Utah to Ellington Air Force Base and brought here to Building 31, where we are now. And it was safely brought into one of our large glove boxes behind us that first day. The next day, our team was able to remove the canister lid, and that gave us our first glimpse of the tag SAM head, but also a surprise in that there was sample outside of the tag SAM head within that sample canister. That was kind of an extra or bonus sample for us.
Well, what an honor to be standing right here, so close to the sample with you today. So you mentioned that bonus sample. What have the initial findings been for the curation team?
Yeah, it's a combination of fine dust as well as some what we call intermediate sized particles, particles that are roughly the size of the short width of a grain of rice, which we've carefully collected, and also have already allocated some to the science team, the sample analysis team, which you'll hear a little bit more about from Dante and Danny in the quick look analyses.
And of course, this is not just a NASA mission. There have been several partners along the way. Can you tell us a little bit more about how many scientists are working on this?
Yeah, so we have two incredible international partners, JAXA and CSA, and also the sample analysis team includes over 230 scientists from around the world who will really intensely work on studying some of the sample for the next 2 years. We'll also have 3 samples go to museums in the next couple months. So folks at home may have the opportunity to go and see the sample themselves at the Smithsonian in Washington, D.C., the University of Arizona Museum in Tucson, or at Space Center Houston right here in Texas.
So exciting. So what does it mean for your team to have seen this clean room built from the ground up and now to see the sample in it? I'm sure it has to be so exciting.
Oh, it's incredible. So this clean room was constructed very specifically for the OSIRIS-REx sample, since the scientific goals of this mission are really tied to the building blocks of life and organics. Organic contamination was a really detailed concern to us throughout the entire design and construction process and outfitting. So everything you see in this lab was carefully reviewed to make sure it wouldn't contaminate the sample so we can get the most scientific benefit out of this return.
So can you tell us a little bit about how long it will take to fully reveal the sample and where the sample will live?
Yeah, so the sample's permanent home is this lab behind us. But what will actually happen next is we'll continue taking the tag SAM apart. So right now we have this incredible view of the sample into the tag SAM. We're looking into the part that touched the asteroid Bennu. We're actually going to take those parts off to get a little further in so that we can then distribute that sample into bulk sample handling trays, which are triangular and look sort of like deep dish pizzas.
And for scientists interested, how will they eventually be able to request a sample?
So in about 6 months, we will release a sample catalog, which will give scientists from all around, even beyond the sample analysis team, enough information to start to think about what science questions they want to ask, and they can propose studies and specific quantities of sample they would like to use. And then those requests will be reviewed by a peer review allocation board. And then those who are granted their requests will get samples in the next 9 months or so.
All right, well, Nicole, thank you so much for joining us today. And as you can see, we are just beginning this process